All right, so today I'd like to teach you about a new form called vertex form. And what I mean by new form is a new form of a quadratic. We've seen standard polynomial form, we've seen vertex form, and each of them has their advantage. So standard polynomial form has the advantage of showing you the y-intercept. Factored form has the advantage of finding the x-intercepts easily. And then vertex form might give you a little clue. So again, for a quadratic, the vertex is the max or min. So if I'm trying to find the vertex, we have this whole new form, which is in the form a times x minus h squared plus k. And why we write it that way is that helps us find the vertex. Now it's very important that there's a subtraction in here, but you can see it's a totally new form of how we look at it. But we have this quantity squared, so eventually if I did expand this, it would make a quadratic. So I've graphed x plus 2 squared minus 9 right over to the right here. If I go over to GeoGebra real quick, I'll show you something neat. I have some sliders here that I have my equation in there, but watch what happens when I move my h and k. So right now my h and k are at -2 and 2. And I want you to look at what happens to the max or min. So if I move my h, let's say to the right here, notice that the parabola just moves straight to the right. And k, I can move it down to there, or up to, we'll say 4-ish. Okay, or over to 3. And notice that that minimum value is at hk. And if I flip it, doesn't matter if the a value changes. So what happens, what's awesome about vertex form, is that the vertex of our parabola is at a h comma k. No matter what, no matter what, no matter what. So what's tough sometimes is to see what our h and k are. So notice that I have an x minus an h squared. So if I have a plus inside the parentheses here, we have to look at it sometimes like x minus a -2 squared minus 9. But in this case, the vertex is at -2 comma -9. And we'll see different forms, but eventually what we want to see the advantage of vertex form is to get the vertex pretty quickly because it wasn't so nice in our standard polynomial form or factored form. So next, what we want to be able to do when we have the vertex form, we can see the vertex easy, but that doesn't mean we don't have to find other things. For example, we're going to have you find the x and y intercepts. So even if it's in this form, I want to be able to still solve if it's equal to 0. So I have this case, and what I'm going to have you try and do is I'm going to set it equal to 0. So essentially we're finding the x-intercepts. So I want you to pause this real quick and see if you can solve for x. So move around the variables to see if you can get x equals. So pause now, try that. You're just waiting for me. But hopefully you paused, and I'm going to go through this algebraically. So normally a lot of times when we have this, we want to square it and we want to expand it, but the algebra is very different in vertex form. It's actually a lot more convenient in my mind. So I'm actually going to move everything away from this quantity squared. So I'm going to subtract k. I'm going to divide by a. Get -k over a equals x minus h squared. And why I did that is there is a nice speed that I can take the square root of a whole quantity squared. But I can't take the square root yet if I have all that other stuff there. So I can take the square root of both sides. What's probably the #1 mistaken thing is that plus or minus still a common mistake. But it equals x minus h. So now I can attack x. So really, if I want to find the x-intercept of any of these problems, there's a quick little formula. Now we have the quadratic formula normally when it's a, b, and c, but really I can find the x-intercepts by taking h plus or minus the square root of -k over a. And since it's an x-intercept, I might write it as a coordinate just to be thorough here. But this right here, that's always to find any x-intercept. So I'll show you an example with a number here, or numbers here, that if I want to find x-intercepts, I set it equal to 0. And really, I'm going to do the same algebra that I did before. I'm going to add 9. So I get 9 equals x plus 2 squared. I can take the square root right off the bat. Got my squared there. But I get plus or minus 3 equals just x plus 2. Now, when I subtract the 2 to the other side, just be careful on how we're thinking about this. I'm not going to take 3 minus 2. And what you may want to do is break it up to say I have 3, a positive 3 minus 2, and I have a negative 3 minus 2. But that's not too bad. 3 minus a 2 is x equals 1 for my solutions, and then x equals negative 5. If they wanted intercepts, then I'd write it differently. If they want intercepts, I'd go 1, 0, 5, and negative 5, 0. Okay? And just to show you that you can use this formula, it's always nice to highlight what your h and k are. In this case, my h, it's a little tricky, is negative 2. Remember that it's x minus h. So a negative 2, my k is negative 9. So if I plug that in, I'd take negative 2 plus or minus the square root of the negative k, so it would be 9 over a, which in this case is 1. So I'd get negative 2 plus or minus the square root of 3. And that's what I had up above as well. So we get this, or not the square root of 3, sorry, just the square root of 9, which is 3. And that's the same thing that I had up above. So that's a nice little formula for that. The last thing we'll have you find with vertex form is the y-intercept. So we want to be able to find everything. Now y-intercept is just like anything else. We're going to find f of 0. So I'm going to plug that in to give you a general formula. It would be a times 0 minus h squared plus k. To simplify this a little bit, I'd take 0 minus h, which is negative h. But when I square negative h, it's always just h squared. So this f of 0, the y-intercept, is a times h squared plus k. So it's not as clean, there's still plenty of calculations, but h squared plus k. That's your general form for the y-intercept. To show you an example, let's go f of 0. I'd go 0 plus 2 squared minus 9. So f of 0 equals 2 squared is 4, minus 9 is 0, negative 5. Okay, so we can't, maybe the number one mistake for this is I was looking for the last number to find the y-intercept. Well, in this case, if it's in vertex form, we got to do a little bit of work. This is not the y-intercept. So just like everything, or every quadratic, we want to be able to find x-intercepts, y-intercepts, and the vertex, the max or min. But in vertex form, it's very, very easy to find that vertex. It's at HK. All right, try some out on the worksheet.